Name the polygons. So there's a couple on this slide, and then there's a few on the other side. So I'm going to give you a minute to name these. Here, this one has 1, 2, 3, 4, 5 sides. So this one is called a pentagon. And this one has 1, 2, 3, 4, 5, 6, 7, 8. Think about what prefix we use for 8 sides. Again, make sure you complete these as well as the 2 on the first slide. In the video, how does the gift wrap compare to the surface area of the gift? Well, since the wrapping paper overlaps, the surface area of the wrapping paper is greater than the surface area of the gift. Is it possible to wrap a gift by using one piece of paper that has the exact same area as the surface area of the gift? If so, what would this look like? Well, it is possible. It might be a challenge, but the wrapping paper would just barely touch, and there would be no overlapping. How can we use the dimensions of the box in the video to figure out the area of the perfect wrapping paper sheet? Well, we could figure out the area on all the sides of the present and then combine those to figure out the area we need for the paper. In these lessons, we're going to learn about surface area of different types of solids. So we're going to explore a couple of rectangular and triangular prisms today, and then we'll become more advanced with the shapes that we can solve for in future lessons. Here I see some examples of right prisms, and then prisms that are not considered right prisms. The right prisms are where the base along the bottom and the sides create a 90-degree angle, a right angle. So here the sides and the base again create a 90-degree angle. In these ones, it is not a 90-degree angle. Consider this right rectangular prism. Sketch a net of the prism and label all side lengths with their measurements. So a net is like if you were to unfold all of the sides. I like to label my net to help me. I'm going to call this the front, this side the left, this piece over here will be the right. We also have the top, the bottom, and then a piece on the back. So the front is a 7 by 3. Connected to the front, we have the right side, which is 7 tall, but it is 5 wide. We also have the left connected to the front. It is 7 tall and 5 wide. Coming off of the front, there's also the top piece. The top piece is 3 by 5. The bottom piece is a 3 by 5. And then I also have the back, which is a 3 by 7. Then it says find the surface area of the prism. So we're going to find the area of each section, and we'll add them up to figure out the total surface area. A 7 by 5 is 35. A 7 by 3 is 21. A 3 by 5 is 15. And we have multiples of those because we have a front and a back, a left and a right, a top and a bottom. So let's see, 35 plus 21 makes 56, plus 15 would give us 71. Then we'll add another 71 to that. And that gives us 142 feet squared because it's an area. Here we have a right rectangular prism, and we can turn it around to check out different aspects of it. From the top-down view, we can see that the top has dimensions of 3 by 4. The front has dimensions of 4 by 6. And the left and right sides have the dimensions of a 3 by 6. If we were to slice this into 2 sections to create triangular prisms, how do you think the surface area of the triangular prism would compare to the surface area of the rectangular prism? Here it says 2 right triangular prisms are formed by slicing the right rectangular prism in half. One of the triangular prisms is shown in the diagram. Find the surface area of the rectangular prism. Like I mentioned earlier, I like to write down the pieces that I have. So for example, the front, the back, the left and right, and the top and bottom. The front, the dimensions are 4 across, and this one is 6 tall. So 4 times 6 is 24. The back is also 4 wide and 6 tall. The left and right sides are 3 wide and 6 tall. 3 times 6 is 18. The top and bottom are 4 by 3s, which is 12. So the total surface area is all of the values added together. 24 plus 24 is 48. Then we need to add 18 and 18 to that. So 48 plus 18 plus 18 is 84. Then add 12 and 12 to that, which gives you 108 units squared. For the triangular prism, we have a left and a right. We have a top and a bottom. And we have the back piece, but there is no front section here because it comes to a point. The left side is 4 tall and 5 wide. So 4 times 5 is 20. Oh, excuse me. It is not 20. It is 6 and 5, which is 30. The right side is 3 and 6, which is 18. The back is 4 by 6, which is 24. And the top and bottom come from this square, or this, rectangle, which is a 3 by 4, but it's cut in half. So it is 3 times 4, which is 12. Cut in half gives us 6. Add all these together. 30 plus 18 is 48. Plus 6 is 54. Plus 6 is 60. Plus 24 is 84 units squared. So how does the surface area of the triangular prism compare to the surface area of the rectangular prism? Well, just because we cut it in half doesn't mean that the surface area is half, because now we have this section in the middle that is contributing to the surface area. But the surface area of the triangular prism is less than the surface area of the rectangular prism. Consider the right triangular prism. All lengths are shown in inches. Draw a net of the prism. We have a big bottom piece, which is 28 by 28. Then we have a right side, which is 28 by 16.1. And a big left side, which is 28 by 13. Then I have 2 small triangles coming off of the bottom piece, which have a height of 4. Find the surface area of the prism. Well, these rectangles, this is a 13 by 28, so we'll multiply. 13 times 28 is 364. This one is a square that is 28 by 28 for 784. Then I have a 16.1 by 28, which is 450.8. And I have 2 triangles that have a base of 28 and a height of 4. 28 times 4 is 112. But remember, in a triangle, you have to divide by 2. So that is 56 for the triangles. To find the surface area, we need to add all of those pieces together. And when you add all those up, you get 1,710.8 units squared, because it doesn't tell us if it's feet or centimeters. We're just going to write units. Find the surface area of this prism. I have a front and a back. I have a left and a right. And then I also have a bottom piece. The front is a 22.3 by 8 triangle, so I'm going to multiply 22.3 by 8 and divide by 2. And that gives me 89.2 for the front. And the back is also 22.3 by 8, and then split it in half because it's a triangle as well. This left side is a rectangle that's tilted. It is 15.7 by 23.7. So we will multiply those two values together. It is just a rectangle, so you don't have to divide by anything. Oh, the left and the right side are not the same in this one. The right side is 8 tall and 15.7 wide, which is 125.6. The bottom is 15.7 by 22.3, which is 350.11. Then we will add all of those values together to find the total surface area. So 89.2 plus 89.2 plus 372.09 plus 125.6 plus 350.11 comes out to 1,026.2 units squared. Again, it doesn't tell us if it's feet or centimeters or yards, so we just use units. Make sure your workbook is filled in for lesson 17, please, and then check back when you're ready for the next lessons.